Yes, so, it's an amazing thing to be here. I spoke at the MDS Summit, so I'm excited to be back in Bangalore. So, technology is an amazing thing. I'm actually taking this Gid's Edge concept very seriously and going straight to the edge of technology. But of course, my slides, I need a Mac adapter, so it's going from the sublime to the ridiculous. But what I'd like to do today is talk a little bit about something a little bit more futuristic. So this is a concept that I've been developing called consciousness prosthetics, and it's basically really about moving towards the edge of human-computer interface. So very interested in kind of pushing. I live in Silicon Valley. I live in San Jose, up by the mountains of Los Gatos, and I get into a lot of conversations about technology. There's a huge hotbed of technologists there, much as there is here in Bangalore, and I've gotten involved in a bunch of different networks. I got involved in the Java Technology Network by joining Sun Microsystems back in the early days of Java, so I got to rub elbows with the creators of Java and talk about the technology with them. Pretty exciting. I joined a venture capital firm as a limited partner called Focus Ventures. Right now I'm working with a company called Key Corporation, KII, and we're working on mobile backend as a service. But today my focus isn't to talk about Key, it's to talk about this future edge that I call consciousness prosthetics. So in the Valley, we talk a lot about this concept of exponentiality. So, everyone's familiar with Moore's law and the doubling rate of computer processing and this type of thing. One of the things that a friend of mine at BC posted on Facebook is this thing he calls Rose's law, which is the doubling speed of quantum computing. And, one of the really funny things about this chart is there's actually a point on this chart that says faster than all computers and then faster than the universe. So I had to ask him, what does it mean when quantum computers are faster than the universe? So apparently there's a theoretical limit to computation speed, and they said if they built a computer that had every atom in the universe computing at the maximum speed, then that would be the limit of computation speed. So, all of this is extremely exaggerated. Who knows if quantum computing will reach this speed? As well, quantum computing right now is limited because these are very functionally focused devices, right? These are discrete optimization problems, not general purpose Turing computers. So here we have this wonderful property of technology, which is exponential growth. And you guys are, I'm sure, familiar with this story, so I'll keep it brief, which is, there was a mathematician that lived in an ancient kingdom, and he basically did a good deed for the kingdom, so the king wanted to give him a reward. So basically the reward was, basically anything he asked for. So the mathematician said, I'd like you to place 1 grain of wheat on the first square of a chessboard, and then 2 grains on the second square, and then 4 grains on the next square. So, just doubling each square to the 64 squares on the chessboard. So the king, of course, not being good at math, said, okay, sounds great. So the net result was that the king ended up owing 18 quintillion grains of wheat. So it's a pretty serious math problem. And obviously the king chopped off the guy's head. There's a lot of stuff in Silicon Valley around exponential growth. This guy, this is Ray Kurzweil. He started something called the Singularity, and he talks a lot about exponential growth of technology. And where this guy goes is he goes to things like consciousness being uploaded into computers and stuff like that. And I just can't help calling bullshit on this guy because I don't believe that he understands enough about computers. He has this little chart in the upper corner where he says that the compute speed of digital computers will exceed the compute speed of the human brain. So my problem with this as a trained neuroscience neuroscientists is that we don't actually know the compute power of the human brain. It's analog. So, it's not a fair comparison. So, you can hide a lot under an exponential curve. But one thing that doesn't seem to evolve at an exponential speed is the human brain. Now, you could argue that the evolution of the neocortex in recent evolutionary history was an exponential expansion of function over what had existed previously. But really, all of that kind of stuff is taking millions, if not billions of years. So brain evolution is exceedingly slow, and that is problematic. So why are rates of evolution important? Because we have big problems, right? So we have these very large problems that we're grappling with in society, and we have big problems, so we need big solutions. We need answers. So we need superheroes. So you guys may be checking this movie out soon. And we need superpowers. This is kind of an interesting picture, actually, and this connects directly to the theme of my talk, which I call consciousness prosthetics. So this is a guy, Oscar Pistorius, who has prosthetic limbs, and yet he's one of the fastest human beings that you'll ever find. So he's a runner, and he's an extremely fast runner. The concept of prosthesis is typically about taking something that was removed, like a limb, and restoring its function. When I talk about consciousness prosthetics, what I'm really talking about is the ability to expand our awareness past the limits of what humans normally can. Another interesting thing about this story is that Oscar Pistorius is actually kind of in a court case right now because he actually got arrested. He's a South African athlete, and he was arrested for murdering his girlfriend. So it's a pretty serious case, but I just want to characterize this as interesting because you have superhuman powers, you have superhuman speed, but you still have problems. And I'm not saying whether he's innocent or not. I don't know, but problems continue to exist. This guy is someone who I spoke on a panel with at Cornell University, Hod Lipson. So he has this amazing technology. So Neil talked about the laws of robotics. So his robotics technology is actually these machines that achieve an awareness of their body. And the way they do so, it's very interesting. You can have he had a 5-legged robot that was moving around. This is actually a 4-legged robot, but he had a 5-legged robot, and he actually cut one of the legs off. And it was actually able to adapt and figure out how to move. And eventually, the models that it was using to construct its movement changed so that it became aware that it only had 4 legs. So it was very interesting to watch this development. Very interesting concept. So this video is more about software evolution. And what we're seeing is an evolved 3-dimensional organism. So this organism is basically a set of connected blocks. You can apply evolutionary algorithms to effectively evolve movement behavior. And what we're trying to, what the inventors of this were trying to do is to evolve coordinated movement behavior. And when I talk about evolutionary algorithms, I'm really talking about a mechanism where you just compete many different random organisms against one another. And this one happens to be reasonably efficient at traversing the ground. Obviously, if there's a set of organisms that are inefficient, those organisms are killed off by the algorithm. And the ones that are efficient at traversing the ground are obviously given the chance to reproduce themselves. Modern day sophisticated evolutionary algorithms actually are able to reproduce sexually. They're able to recombine their capabilities with other successful organisms. So it's a pretty amazing technology, evolutionary algorithms. In this case, they're actually changing the environment. So in this case, the environment now is a rough textured surface as opposed to a smooth surface. And as you can see, this organism is reasonably well adapted to traversing a rough surface. Obviously, when you change the gains of the evolutionary conditions, you'll see a lot of different creatures that evolve out of that. So one thing that's important to note is the evolution of hardware. So as I mentioned, Moore's law dictates the evolution of transistor density on semiconductors. But really all of that has to do with the fabrication technology and the rate of evolution of fabrication technology. As we know, a specific instance of hardware does not evolve, right? So what this dictates is it dictates the necessity that more and more things are manifested in software and are solvable by software. Another guy who I spoke with at a similar conference is the CEO of Twilio, Jeff, and I cribbed this slide from him. He has this whole thesis that we're all software people, and we're in a great place in time because more and more problems are turning into software problems, right? So if you look at the UI of a phone today, it's basically a piece of glass, and you can put any buttons you want on the glass, right? So obviously this particular phone has fixed hardware buttons, so it's unevolvable. But what's happening is that everything is increasingly becoming software, and more interestingly, it's increasingly becoming a set of APIs. And so I'm going to talk a little bit more about some very unusual APIs later in my talk, but as you can see, more and more things are becoming solvable as software problems. And here's a case where hardware is solvable as a software problem, which is the case of what Todd also calls programmable matter. So this picture is actually the first 3D printed gun. It actually fires real bullets, and it's a fully lethal weapon. It is made out of this kind of strange polycarbonate plastic, but it fires metal bullets that presumably can kill people. So coming back to the topic at hand, what is it that I'm referring to as consciousness prosthetics? And to me, the interest in this topic that I have is, it's sort of an exploration that I've been on over the past 5 years or so. But what I'm really trying to point to is a region where there are three rapidly evolving, actually one not so rapid, but there are three evolving components that may surface as one of the next big things. I know developers are always out looking for the next big thing, a big platform, so I'm proposing that there's something interesting that's forming over here. These are the three areas. One of them is wearable and sensor technology. So when I talk about wearable and sensor technology, this is inclusive of all of the smartphones that we carry. Obviously, each smartphone has about 16 sensors. We expect in the next 5 years that will double. And the number of sensors are probably going to continue to double at an astonishing rate. So what these devices will be able to detect expands exponentially, and the penetration of the devices expands exponentially. I mean, if you look at the 1.7 billion devices shipped by the industry per year, Earth only has 7 billion humans, so it'll be on short order before there are more smart devices on this Earth than there are humans. Another trend that is very interesting and evolving quickly is quantified self and big data. So I'm a kind of member of the Silicon Valley Quantified Self. Really interested in, and this may be the laggard, is mindfulness technology. And the reason why I think mindfulness technology is so interesting is because it has to do with the brain itself. And as I mentioned before, the brain is an evolutionary laggard. It does not move very quickly or change very quickly. And so how do these three segments all interact? So, to me, I think wearable and sensor technology is probably one of the most expansive portions of what's happening. So when I talk about sensor technology, I think it's really important to try to understand that sensor technology. I think when people look at telephone, right, the original model of a telephone is the notion of extending hearing beyond normal physical ranges, right? So you can talk to people, or extending your voice beyond a normal physical range, bending space and time, right? So one of the things that's great is the ability to sense things that are very microscopic, things like proteins, things like DNA, other kinds of extremely small components. When you start to see the beginning of wearable technology, you start to see very kind of gawky, geeky products. You guys have probably all seen the Google Glass stuff. I'm sure there's probably a Google Glass owner of the developer kit somewhere in the room. It's a pretty amazing emergence, but it's definitely just the beginning. I have a feeling this is going to be slow to adopt in mass adoption. So the second thing that I wanted to talk about is big data and self-quantification. Visualization kind of comes with this. This is kind of an interesting demonstration. It's basically a guy who has hooked their Kinect, the Microsoft gesture interface, up to a big data set. And the big data set, it's kind of an interesting data set actually. It's graphing 3 dimensions. One of them is GDP per capita, which is about the development of a given nation. Each of these dots represents a nation. And then life expectancy is another one of the axes, right? So as you can see, and these are color-coded by region. So you can see African nations, you can see East Asian nations, etc. And what he's done is, manipulated by time axis using the gesture interface. So, you can actually start to see, obviously individual countries, he's pointing them out, and you're able to see, the various bits and pieces of this. How does this emergent technology intersect with all of these kinds of other technologies? To me, self-quantification is going to produce very big data, even just coming from a single individual. But as you can potentially imagine, as you start to intersect self-quantification data across millions of consumers, you start to develop some potentially very interesting data sets for mining and crawling. One of the targets for mining really large data sets in big data is using evolutionary algorithms to crawl the data. So you can actually ask the crawlers to do, very interesting evolutionary things. The reason why this makes sense too is one of the major interfaces to big data now is MapReduce. MapReduce allows you to effectively programmatically crawl the data and draw data out of the large data sets. So I think that technology potentially poses a very interesting component. So the last of the triumvirate, this is actually a Facebook friend of mine. He has the unlikely name of Mike Matsumura, and my name is Miko Matsumura. So I ran across him in a really strange way because someone mistook me for him. But he's a yogi. He's based in Colorado. And the reason that I'm not really pointing this video out to feature him at all, but what I did want to say is, mindfulness technology is actually pretty old. It's actually thousands of years old. And in fact, the roots of mindfulness technologies, to me, come from India. It's exciting to be here and to learn more. If you think about the reason why this technology has meaning today is because the brain evolution is very slow. So when people studied the mind 1,000 years ago, 1,000 years ago is an unmeaningful amount of time from the purpose of brain evolution, right? So people are dealing with the same kinds of issues. As yoga is practiced in the West, there's a very strong emphasis on kind of, physical postures and whatnot. But I think ultimately the most interesting part of this is the mental part, which is how does the brain manage and deal with itself. So, as for myself, I had a very strange midlife crisis, being a nerd, right? So at the age of 40, I basically went on a kind of a self-quantification rampage, and I started conducting a lot of personal experiments in what I would call cybernetics. So I'm not really a cyborg, although you could look at me that way. One of the things that I wanted to quantify is sleep. it became pretty obvious that I was sleeping really badly. I was actually about 40 or 50 pounds heavier than I am today, and I had kind of crippling sleep apnea. It's where you stop breathing at night. Pretty bad. So I went in for a sleep study. I mean, this is an amazing technology. I don't know if you guys have looked into sleep studies. I highly recommend it. You get totally wired. You get electroencephalography. You get electromyograms. You just get totally wired, and then they just record everything. It's a nerd paradise. The only thing it doesn't have is an API. It's kind of irritating. But so I went in for my own sleep study, and they discovered that, in fact, I had such bad apnea that I took a corrective measure. The corrective measure was a surgical procedure called genioglossus microtubule extension, which basically involves cutting your skull and inserting a titanium screw. So actually I have a titanium screw in my chin here. This is not my x-ray, but my x-ray looks the same. It looks exactly the same. If you look at the little green arrow, you can actually see that there's a screw there. And that the tongue, the muscular insertion point for the tongue is advanced by almost a full centimeter. So it's actually using the architectural ridge of your jaw to pull your tongue out of your throat. It's quite an astonishing piece of technology. But to me, the result was nothing short of miraculous, because suddenly I was sleeping at night, whereas before I never was. So this is completely transformational. Because of, and by the way, the sleep analytic technology of a sleep study is now available at a low price of $80 US. I don't know if you know about the Zeo sleep band, but you can buy one of these, stick it on your forehead, and this is the poor man's EEG. What's great about it is this sensor is much more primitive than a real EEG sensor, which will cost you about between $15,000 and $30,000 US. But what it's doing is it's using a neural network that converges to a much simpler data problem, which is you're not actually recording large-scale neuronal population rhythm. What you're actually doing is you're reducing that into 3 possible states. Actually, well, you're either awake, you're in REM sleep, or you're in deep sleep. Right? So that problem becomes very solvable and in software, and then you get this data, which is very helpful. So after I got my sleep back, I started becoming really interested in oxygen metabolism. And I got interested in that because I could breathe again. So I took this study called the VO2 max, which basically measures the maximum amount of oxygen that you can consume over time. It's pretty intense, actually, because they stick you on a treadmill, they set up your gas consumption, and then what they do is they make you run, and then what they do is they set the incline. So pretty soon you're running up a hill as fast as you can until your heart explodes. Actually, they stop before your heart explodes, but it's pretty close. It's extreme. So I measured my VO2, and with that data, I actually started training. So I eventually ran in the San Francisco Marathon, which I was proud of because I was kind of a bad guy, and now less so. I got into heart rate measurement. You can actually understand the lactate threshold, which is the speed your heart beats. And if it beats any faster than that, by 1 beat per minute, your body starts producing lactose in the muscles, and you can't sustain it. It's very interesting physiology. And then I got into the stuff called heart rate variability. This is very interesting, which is that the autonomic nervous system speaks to the speed and the variable heartbeat of the heart. If you want to study this stuff, you can just go to heartmath, math.com. It's kind of an interesting thing. These guys have equipment that you can buy that allows you to measure your heart rate variability, which has to do with your mental state. And you can actually increase your heart rate variability by doing a bunch of essentially meditative practices. Kind of interesting. Tons of people have done this one. Use the laser to correct your vision. Great idea. Works so far. It's worked well. I got part of my genome sequenced. So this is another bargain. So 23andMe, you can actually, for $99 US, you can get thousands of pieces of your genomic sequence analyzed. So now I know that I'm in the 99th percentile for Neanderthal DNA. So this is what a modern Neanderthal looks like. And I use this scale, the Weyling scale, to measure my weight and my fat content pretty much daily when I'm at home. This is an awesome product. I'm not connected with the company at all, but it's cool. Step on the scale, measures what it measures, and then it does it by Wi-Fi. Sends it to the website. You get these cool graphs you can look at on your phone. I don't know, eat paradise. No API. The heck. I got interested in blood glucose monitoring. So this is like a really kind of stupid thing. So I like voluntarily stab my finger like on a regular basis. It's really crazy. This is the deep end of the pool for nerd stuff. Excuse me. So I got interested in this blood glucose monitoring, and it turns out that there's some really good systems for doing blood glucose monitoring. And it turns out that human beings actually are not that good at it. This is the original classical blood glucose regulation system, which is if your blood glucose gets very small as a baby, then you cry, and then your mom shows up. So that's basically the original regulation system. And this pattern kind of extends itself into young adulthood. I mean, when I was a young adult, I basically followed the same pattern. My blood sugar would drop precipitously, and then I would cry. And then I would go find some cookies, right? So it turns out that there's new technology for this that transcends even the so-called CGM systems, continuous glucose monitoring systems that have an implant, right? So this technology is even better. This technology consists of a bunch of nano networks, and the nano networks actually contain glucose inside of their matrix. And what happens is that you just inject this stuff into your blood. The stuff circulates around your blood, and then when your blood reaches a certain low threshold, actually it's a high threshold of blood glucose, these nanobots actually release insulin. Right? And so it's pretty amazing technology. They can these guys can stabilize blood sugar in mice for up to 10 days on a single injection. Now, these guys have never been injected in humans, and it's probably good, because I'm not sure if this is safe yet. But to me, it's interesting because this is a autonomic system of regulation. It's not one that requires conscious awareness and data collection, but it's still kind of an interesting paradigm. But the guys who I really like in the bloodstream biz is this company called NanoBiotech. And these guys, if you go to their website, you're going to see nothing because it's just a stealth company. But I think they just raised, I think it was over 40 million. I don't remember how much it was. They raised a huge venture round probably 2 weeks ago or so. And their whole pitch was around what they call the bloodstream API. So for nerds like myself, I get really excited, right? So what does that even indicate that there's a bloodstream API? So what they're really talking about is they're talking about implantable and non-implantable sensors that give constant data streams of every kind of blood chemistry. And all that blood chemistry is accessible through an API, which is pretty neat. Now, there's 2 dimensions to that. One dimension is that helps people with continuous monitoring of vital signs, right? So the medical implications are huge. But I think the second thing that's interesting is that the data streams can then go into a big Hadoop. And everyone can now get this huge data set to kind of analyze what blood looks like. And it makes blood into something programmable. And when you think about the interaction between these kind of nanobot technologies and this kind of bloodstream API, you start to think about a future for human health that's kind of intriguing. So here's kind of an anti-pattern for human-machine interaction. I don't know if you recognize this device, but this is the magical and revolutionary Newton Message Pad 2000 from Apple. This is probably one of the first personal digital assistants, and Apple launched this thing. And one of the things that this device did is it recognized your handwriting, or at least it supposedly recognized your handwriting. It was terrible. I bought the Newton 1, which is I think it was the especially to this, and yes, it was terrible. So, this device eventually didn't work out. Sometimes brains are much better than machines, and I'll show you an interesting example. So this device is a camera for blind people. So what does that even mean, a camera for blind people? So the way it works is, it's pretty interesting. So what happens is that you have a camera, and the camera sends the image to a handheld control unit. So what happens is the control unit is now recreating the image of what the camera sees on a grid of 400 electrodes that are pulsing. And what happens is that the subject actually puts that pin grid onto their tongue. So now this person can't see, but they can feel what the image looks like. Right? So it turns out that over time, initially this data is extremely confusing. It's kind of like Braille for looking at a scene. But it turns out that over time, the brain is capable of adapting to this device, and is capable. People learn how to navigate in a room. So they can actually walk around obstacles, and they can successfully deal with this kind of sensory input. It's pretty shocking. And to me, the take-home lesson about human-computer interaction is sometimes the brain can be made to evolve. There are really amazing cases. For example, there are cases of people who are born with only one hemisphere of the brain. And if you actually study these people, you learn that the other hemisphere of their brain is just cerebrospinal fluid. It's just basically water, right? These people actually are able to establish almost all of the functions of a complete brain. And what's occurring is that the brain is adapting radically to its new configuration. So I think this is an interesting lesson that indicates that programming to the brain API could be interesting. So this is one of the self-quantification experiments that I conducted on myself, which is I saw a lot of people trying to measure human intelligence at varying degrees of success. So what I wanted to measure is stupidity, in particular my own. And so what I did is I started a daily mindfulness meditation practice. And what I did is I actually looked and I recorded. It was very short. They were 5-minute meditations. And during those meditations, I recorded all of the stupid thoughts that came into my brain. And I was pretty excited about this project. It turns out that there's time. If you look at these things that are coming up, like loneliness, fear, greed, vanity, vanity, loneliness, vanity, irritation, hope, fantasy, vanity, greed, irritation, lust, vanity, vanity, fear, vanity. So you get the idea. It's terrible in there. It's like I discovered that my mind is filled with incredible amounts of stupidity. Very interesting. An interesting project in self-quantification. The Quantified Self community responded pretty well to this. They thought this is fun. So kind of what I learned is that in my case, there's this concept, this self-concept, and the self-concept is constantly trying to defend itself. So it's a very interesting mental frame. And to me, it indicates that the brain is an evolved IT system, and that the function that it's being evolved towards is survival. Right? So this survivalistic mind is part of what's built into our hardware, and it's part of our legacy as humans. So I kind of wanted to give you a bit of a nugget here, which is, there's an entire conference that SaltMarch puts on around gamification. And gamification is getting more and more exciting. And I just want to indicate to you guys that gamification is brain programming. Why is it interesting? So for example, if you look at the game of Pac-Man, Pac-Man is based on 3 fairly simple principles. One of them is will it eat me? So when the enemy presents a threat, right? The second concept is, hey, can I reproduce with this entity? And then the third one is, can I use it for nourishment, right? So these 3 kind of very primitive impulses are built into gamification, right? And these are all from our human limbic system. So this is a very intrinsic thing. Other parts of gamification that are really interesting are things like collection and completion behavior. Why is it that when you collect a full set of something, you feel satisfaction? You know, also very well documented. So this is brain programming. So to me, this concept of consciousness prosthetics, the reason why I use the word prosthetics is a prosthetic device is designed to realize the full potential of a human. Even if they don't have their limb, they can realize their full potential. And so how do people realize their full potential? So this is kind of interesting research, which is, it's about rewiring the brain. So, you know, in this research, what's effectively been done is they're measuring glucose transport within the brain. And so this glucose transport is thought to be a proxy for which parts of the brain are being used at a given time. And what they measured is they measured folks that were using a meditation practice, and they were looking at how people who use a meditation practice experience pain. Now, the pain that they induced in this research was they took a heated metal object and they pushed it against a person's leg. Now, there are limits to how hot it can be, and you know, there's human subject experiment limits, but it's pretty hot and it hurts. And what they discovered effectively is that there are differences between people who practiced meditation and people who have not. And what happens is there are certain regional parts of the brain, like, you know, and I'm not going to go into a huge amount of detail, but, you know, cingulate cortex and the insular cortex, a lot of really interesting parts of the brain being activated by this type of technology. It's effectively a selective preference for data input and a selective depreference of narrative input. So what's interesting is that, you know, I talked about all those crazy stories that pop into your brain. Well, this is a trained method where a human being is trained to prefer just the raw data. And that's from a self-quantifier perspective, that's very interesting. So I spoke with the head of the Calming Technologies Laboratory at Stanford University. This technology I thought was very interesting, which is they measure the breath, and they measure what happens to the breath. One of the things they discovered is something that they call email apnea. So it turns out that during email sessions, there are certain moments where a person stops breathing. And, you know, you can just record those moments, right? So one of the things that they're working on is they're working on how people can become increasingly aware of their breath patterns within work environments, so that they can be more effective at, you know, training their attention and focusing on their work. It's interesting research. This is another interesting self-quantification research, much less formal actually. Nancy Doherty, who used to be with Proteus, who just switched companies to Sano, which is the company I referred to. She actually did this amazing study. So she has this technology where pills can actually detect when they're being swallowed. And when the pills go into the body, they start transmitting data to, actually it's through Bluetooth. Right? So it's very strange. And what she did was she created a bunch of pills that she called mindfulness pills. And every time she needed more willpower or more calming or more focus, you know, she would take one of these pills. And then she recorded, you know, it's fairly subjective, but, you know, what was interesting about this experiment was that the actual technology of the pills allowed her to quantify when they were taken and the net results. But again, a kind of an interesting experiment. So, you know, to me, what's also kind of interesting now that I'm a parent is trying to figure out, like, from a technology adoption perspective, you know, what should we be teaching our kids? You know, whether it's Angry Birds or in this case, Twitter. And so I think that's my conclusion. Just a final note. I'll be talking a little bit more about this later on in the conference. So I work at a company called Key. We provide mobile backend services. This is developer.key.com. You know, you might have heard of some of these companies, but it basically allows you to have an instant server backend for all of your mobile applications without writing any server code. It's pretty interesting stuff. I'm not going to belabor this very much, but I did want to just mention that we are conducting a contest called the Key Cloud App Challenge. And the Key Cloud Challenge basically has about almost $50,000 worth of prizes in it. So, you know, if you guys are interested, it's key.challengepost.com. You can enter it there. It's pretty interesting stuff. So I'm going to wrap up there. Thank you guys very much. I'll be around during the week, and I have some more keynotes to do. So thank you.